Welcome to the Ty Beal Show, where we discuss food, science, and life. I'm Ty Beal, a scientist at the Global Alliance for Improved Nutrition, or GAIN. My guest today is Dr. Stephan Guyenet, a former neuroscientist and author of The Hungry Brain, a Publisher's Weekly Best Book of the Year. Dr. Guyenet is also the founder and director of Red Pen Reviews, which publishes expert reviews of popular nutrition books. In our conversation, we explored diets, obesity, navigating health information, and his work in international development. Our conversation includes a frank, research-based discussion about weight and obesity trends from a public health perspective. A quick note before we start. This podcast is separate from my role at GAIN. Okay, let's dive in. Stephan, welcome to the show.
Thanks for having me here, Ty.
So you are an expert on diet and obesity. And I'd just like to know, and I'm sure the listeners would like to know a little bit about what drew you to that. And you're also a neuroscientist. So what drew you to that field?
Yeah, so I've always been interested in fitness and health, even from a young age. And I've always been interested in science and interested in scientific frontiers. And the brain is one of the greatest scientific frontiers. And so I studied biochemistry in college with the idea that I would use that as a foundation for neuroscience. I went and got my PhD in neuroscience at the University of Washington. And at the time, I was studying neurodegenerative disease, but I was studying a relatively rare disease, and I wanted to study something that had more impact. And so I ended up, for my postdoc, moving into the neuroscience of obesity, which kind of brings together my two interests in fitness and health and in neuroscience.
Awesome. Well, I've read your book, and I'm sure we'll talk a little bit more about that later on, but I've listened to you speak and kind of communicate. So I'm really excited to dive into this because you're really good at translating complex topics like obesity and the brain and how that impacts our health. And I just want to kind of get a little bit of a background so we know like what causes obesity. We know that it's risen substantially. You know, if we think about the US specifically, you know, in the last 20 to 30 years, obesity has skyrocketed along with all these chronic diseases. So can you just give us a little bit of an overview of what causes that? What's causing this rapid increase that has only really started to shoot up in the last few decades?
Yeah, so I'm going to start by giving you just a little bit more background on what the trends have been. We have data in the United States going back to 1890 and 1900 in white Civil War veterans, so middle-aged white men at the time. And those data suggest that fewer than 1 in 17 white middle-aged men have had obesity at that time.
Wow.
Today, it's closer to half. And so there's been an extremely large increase in the prevalence of obesity. And in fact, so those data, you go back further and further in time and the data become more and more spotty, right, and less reliable. The first really reliable data we have are from the 1960s. And already by the time we get to the 1960s, from those earlier data in 1890 and 1900, there's already been a several-fold increase in the prevalence of obesity. So we talk about the obesity epidemic starting in the 1980s, and there was an uptick in prevalence, kind of an acceleration. But the obesity epidemic actually has its roots more than a century ago. So we've been getting fatter for over a century in this country. And so that's one thing to keep in mind. And if we go back even further and we look at cultures that are subsistence farmers or hunter-gatherers, we see even lower rates of obesity. So in hunter-gatherers, of all the ethnographies I've read of hunter-gatherers, I have yet to find a single example of a traditionally living hunter-gatherer who has obesity.
Wow.
I've not seen a single one. I don't know, maybe there is one somewhere, but it has to be extremely rare because I haven't come across a single example in all the studies and all the ethnographies I've looked through. So I think the ancestral human condition is not obesity, right? That's a unique modern condition. And so that's just a little bit of background. So what's causing this? Well, at the highest level, we have two options. It's either your genes changing or it's your environment changing. And I don't think genes changing can explain this. And so it's something about our environment that has changed. And really what's happened around the world is as societies have industrialized in terms of their diet, in terms of their lifestyles, that's when obesity starts to spike. So you have these cultures that are subsistence farmers or hunter-gatherers, and then suddenly they get industrial food, industrial conveniences, and then suddenly they have prevalence of obesity that rivals the United States.
Wow.
And so it's something that's changed about our environment. And I think that the primary culprit is our food environment, including the types of food that we eat. And I don't think that's the only explanation. There are probably other ones like physical activity, maybe other things like stress, sleep. But if you want to modify body fatness in animals and humans without changing genetics, diet is the most powerful lever for doing that. And so I actually think we can draw a lot of lessons from the rodent obesity literature. I was a rodent obesity researcher primarily. And I think the way that rodents respond to diet is actually quite similar in many ways to how humans respond. If you look at the studies that have been done in rodents and you compare them to human randomized controlled trials, often the responses are actually quite similar. And what you see in rodents is if you give them an unrefined diet that is made primarily of whole grains and beans with a little bit of animal protein, good micronutrient levels, lower in fat, lower in calorie density, and you give them exercise, you give them an exercise wheel, which they use liberally, they will not gain fat as they age. They'll stay relatively lean and healthy as they age. If you take away the exercise, they'll gain a little bit very slowly. And by the time they're old, they might be a little overweight, but they won't develop obesity.
Okay.
If then you replace the diet with calorie dense, refined food, like we call these quote unquote high fat diets. It is high in fat. It's not just high in fat. It's also high in calorie density. It's refined. It's more palatable, more seductive than their regular food. They greatly prefer it. That kind of diet will create frank obesity in a susceptible strain of rat or mouse in like a month.
Wow. And that's with access to exercise or movement.
Well, yes, with or without typically, but exercise does attenuate it. So they won't get as fat if they're allowed to exercise. And again, they exercise a lot. So it's a pretty high dose. Like if you put a wheel in their cage, they'll use it a lot. But it does attenuate it, but it doesn't prevent it. Okay. And the most fattening diet that you can give to a rodent is easy access to a wide diversity of calorie dense, highly palatable human foods. That is the diet. Basically, much of what we eat in our normal lives is extraordinarily fattening in rodents compared to anything else, even compared to those high fat purified pellets I was telling you about. It's more fattening than that. So there's no macronutrient composition that can explain how fattening it is. It's more than that. It's about the seductiveness of it in part and the variety of it. So we live in an environment that is brimming with foods that in any other species, not any other species, I should say, in species that can gain fat, that are omnivorous and can gain fat, in any of those species will rapidly produce obesity. And we live in an environment that's absolutely saturated with those foods. And so to me, that's the primary culprit. And part of it is the types of foods. They're low satiety, they're refined, high calorie density, the composition. But part of it is the environment. We live in a very enabling environment, right? Like there's food all around us. It's extremely cheap. It's in the checkout aisle at the hardware store. You can order it to your door, pre-cooked meals. Restaurants are historically cheap, at least in the United States. So it's about the types of food that are available. It's also about the variety. It's about the convenience and the enabling environment of it as well. And I think all that together is the primary explanation for the fact that we have an obesity epidemic today.
Wow. So it's the food. It's the food, not just that we are eating, but the fact that we have this food environment, which is really all of the food around us. Where do we get it? Every time we go out into the public, we're usually bombarded with something, whether it's ads or in the grocery store. We see in the checkout lines, we see a lot of foods that are obviously appealing. We may not be hungry, but we see that package and suddenly we're like, okay, maybe I'll have a little treat. So what about modern hunter-gatherers? You talked a little bit about hunter-gatherers. Are there any examples today where we see modern hunter-gatherers that haven't really been affected by the sort of industrial food system? Can we glean anything from that?
Yes. Although the number of hunter-gatherers that still exist today is extremely limited. And I don't think there's any group on Earth, except maybe a couple of extremely remote, so-called uncontacted tribes, that have not been impacted by industrialization and civilization in the rest of the world. However, I think one of the best examples we have, one of the most studied and least affected examples that we have, are the Hadza, who live in Tanzania. And there are some great researchers who are studying the Hadza currently, Brian Wood and Herman Poncer. Herman has some great books where he describes lots of anecdotes and interesting information about them. There's also a really great book called The Hadza that's all about them. And so you were asking about their body composition or what?
Yeah, just thinking of these populations that maybe haven't really been exposed to the food environment today, to the U.S. food system. What is their body composition like? Are they healthy? Are they generally functioning well?
So they are lean by American standards, certainly. But their body composition has been measured, and it's around the range that we would consider close to optimal in our culture. They are very fit. They, have a lot of physical activity, so they kind of have to be fit. This is both the men and the women. They do different types of activities, but they both have to be physically active quite a lot. The men, I think, average about something like 8 miles a day walking, if I'm recalling correctly, and the women is something like 4 or 5. But the women do physically demanding things too. They have digging sticks that they have, and they use them to dig up tubers that many of them look kind of like elongated sweet potatoes. And imagine, like, they're not digging it up in a farm field. They're digging it up in the wild in hard, rocky soil. So they're sitting there with a large sharpened stick, basically like pounding the ground with this thing until they dig these tubers up.
That's not easy. You got to work to eat in that environment.
And they bring in a lot of calories, and those are the most reliable calories, some of the most reliable calories they eat. So the women play a really important role in subsistence. So do the men. The men are primarily hunters. And Yeah, so they are physically fit. As far as we can tell, they are metabolically healthy. So they're not experiencing the obesity associated conditions that we have in the United States, as far as we can tell. There hasn't been a ton of cardiovascular research on them, but they do maintain lower blood pressure, if I'm recalling correctly. I don't think there's been a lot of detailed cardiovascular assessment, but in general, the hunter-gatherers that have been assessed in that way have had very good cardiovascular health. Um, and, I think it's important to recognize, though, that they are not living as long as the average American. So they are dying of things that are different than the things that we are dying of. And
Right.
so infectious diseases, accidents, things like that are much more prominent in those kinds of societies. And especially the infectious diseases, particularly, as you know, affect children. They're most deadly in children, but also in adults. Like if you're living in an environment like that, if you're living in the wild, that's a very, and they live in huts. Like that's a very rigorous way to live, right? Like you're having to deal with temperature extremes, insects, high levels of physical activity. And if you're not able to go out and get your food and your community isn't either, like you're done. So, that's a very rigorous, difficult way to live. And there are a lot of hazards and they succumb to those hazards. And so, and one of the main hazards is infectious disease. And so, it's a very different health landscape than the one that we live in the United States and Western Europe. And the transition from that kind of a health landscape to the one that you and I live in has been called the epidemiological transition. And this is something that's been observed and described in culture after culture after culture, which is as cultures conquer things like infectious diseases and starvation and those kind of like, blunt force health trauma that our ancestors have dealt with for millions of years, then they move into other conditions like non-communicable diseases, obesity, type 2 diabetes, cardiovascular disease, and diseases of old age, Alzheimer's disease. And those are the diseases that become prominent. And one reason is people are getting older, and so there's more opportunity to accumulate diseases of aging, but that does not explain all of it. So, in the United States, many children are obese, right? So you don't have to get old in our environment to experience these diseases. So it's not just about age. It's also because they are not developing obesity. They're not getting metabolically sick. Their diet is more healthy for the cardiovascular system. And I just want to piggyback another point on this while I'm making this point is that you can see similar complexity when you look back at history in the United States as well. Like, I think there's this idea in some circles that we used to be healthy 50 years ago or 60 years ago, and now we're not. But it's a lot more complex than that. In some ways, it's true. Like, we are a lot fatter today. We do have more type 2 diabetes today. But actually, our average lifespan has gone up. Like, people are living longer than they were 50 years ago by a pretty wide margin, actually. It's like almost 10 years. And so, and the main explanation for that is cardiovascular disease. We have way less cardiovascular disease than we did back then. Some of that is from treatment. Some of it is due to changes in underlying risk factors. So it's not just that our medical system has gotten better at treating people. We have less underlying risk factors. And so there's this complex landscape where we shouldn't idealize the past. I think there are lessons in the past that are valuable, very valuable, in my opinion, but that doesn't mean that we should idealize it and say we need to go back to that. I think we need to take the lessons from the past, what they can teach us, and then in other ways, we need to look toward the future.
Right. Okay, very insightful. I want to just touch on one aspect that you mentioned, which is this idea of physical activity and movement. So I'm hearing you that, the main driver of obesity in today's world is really the diet and the environment that we're living in, the food environment. People, may hear, oh, these hunter-gatherers were moving a lot more. And, even the modern hunter-gatherers like the Hadza are moving. So how do we really disentangle the movement from the food, the physical activity or exercise from the food? And maybe to go along with that, what happened over the last 50 years in terms of physical activity? Did we see declines in physical activity? Has it been basically, steady? So that, that can help us tease out these causes.
Yeah, I think we don't have at least I have not seen great data that cover the last 50 years on physical activity levels. I think it's probably pretty safe to assume that they have declined overall, at least to some degree, from 50 years ago in the United States, at least. And the only reason I say that is that we have mechanized away so much of our physical activity. So we think about all the things that we used to do that required energy from our bodies, like walking, riding bikes. We have more cars than ever in the United States. Other things like manual labor that have been mechanized to a great degree. People used to work in factories with their hands, and that still happens sometimes, but a lot less than it used to, right? And then you go back further and there's things like washing machines, dishwashers. We've mechanized a lot of things in our lives. So that said, when you look at the data sets, at least the ones that I've seen that go back kind of to the 80s, so not quite as far back in history. Now I'm like, oh, that was 40 years ago. That was almost 50 years ago.
That's hard to,
that's hard
to believe.
I guess I'm old. But yeah, back to the 80s, there's not really a clear signal that there's been a major change in physical activity in the US. And essentially, what I've seen suggests that work-related physical activity has gone down somewhat, but leisure time physical activity has actually gone up. Like, people didn't exercise for the sake of exercise as much.
You're done working on the farm or in your factory job, and you want to go to the gym for an hour,
yeah. or even an office job, like jogging. People who went out and jogged were kind of weird at that time. I mean, maybe more like in the 70s, but still in the 80s, I think it just wasn't that common. It wasn't as common. Whereas now it's really common, and it's like viewed as virtuous, right? Like people are trying to signal, and it's good for you. It's not just an empty signal, but it's a way that people show that they care about their bodies. And it's like a common socially sanctioned thing that we do.
Mm-hmm.
So yeah, and the other thing is, I think probably the most important signal we have is the results of randomized controlled trials where we have manipulated diet versus exercise. And what we see in those trials is you get bigger effects with diet when you're trying to get people to lose weight, or in either direction. Like if you want to get someone to gain weight, diet is a much more effective lever than making them sedentary. If you want somebody to lose weight, diet is a more effective lever than physical activity. And that doesn't mean physical activity is totally ineffective. I don't want to say that, because it does change body weight and fatness to some degree, but not as much as you'd think. It seems like there is some amount of compensation that happens when people exercise. And the other thing is that exercise is just, the return on investment is lower. It's really it takes a lot of time and effort, right, to exercise. If you're going to do enough to really lose a substantial amount of weight, that's like an hour of your day that you're putting into it. So it's just a lot easier to eat something different because you were going to eat anyway, right?
Yeah.
So I think I've come to the conclusion over the years that diet is just a more powerful lever over body fatness than physical activity is. And they both matter, in my opinion, but I just think diet is more important.
Yeah, well, that's really fascinating. I think a lot of listeners would be maybe surprised to hear that. I think, I've heard from a lot of folks in the health space about the importance of physical activity and exercise. I'm thinking of folks like Peter Attia. I'm not sure if you've read his book Outlive, but he kind of goes into this in certain podcasts talking about, exercise, physical activity, even being potentially above diet for health. And I know he's talking more holistically about overall health, right?
Yeah, I want to clarify that I'm specifically talking about body fatness. And
Yeah.
I think Peter would agree with that.
Right. In terms of levers. Yeah, I want to make that clarification as well too. People often equate, your body fatness with health, right? Like it's not always, people aren't always tracking all of their biomarkers. So it's very easy for people to interpret that, right? As in the US, our big issue is with obesity. As long as I'm not obese, I'm healthy. So I just wanted to kind of clarify that, and also just highlight diet is powerful, right? Especially for obesity. Physical activity for so many other things in terms of well-being. Think about like health span, right? Quality of life, all of that. And certainly other factors of health beyond obesity. So, the last 20 years, data I've seen, kind of what you're saying, there hasn't been a huge change in the quantity of physical activity from the data we have, yet obesity has continued to rise. What, where is the limit? You can't go past 100%. I've seen recent evidence. I think a study came out just a few months ago, maybe a year ago at this point, that maybe was hinting that we've reached the peak. Have you seen this? What do you think? Are we going to turn this around? Where is this headed?
Yeah, I think there's a good chance that we have peaked. Yeah, I've asked myself this question many times because there's got to be a biological limit to the prevalence of obesity in our population. Like, the susceptibility to obesity varies across people, genetic susceptibility. And some people are quite resistant to weight gain. Like, you could probably put them in any environment and they're not going to develop obesity. Maybe they would be more or less healthy, but they're probably not going to, maybe they would have more or less fat, but they're not going to go all the way to obesity. Some people just genetically are not able to accumulate that much fat. And so there's got to be some ceiling, but I don't know what the ceiling is. And honestly, we've gone past, if you had asked me to guess like 10 years ago, we've probably gone past already where I would have guessed. Because at this point, you look at the statistics for the prevalence of obesity in the US, and the latest one that I've seen was the adult prevalence was 43%. That was a few years ago. But that includes 18-year-olds. And so the lifetime prevalence, like your chance of developing obesity at some point in life, is over 50%.
Wow.
I don't know exactly what it is, but yeah, more than every other person in this country at some point in life is expected to develop obesity, not just overweight, obesity, BMI over 30. So that is, to me, extraordinary and suggests that our biological limits are pretty high. But, we have these countervailing forces now, which is that we are developing technology that is starting to push back down on that. And it's like technology and affluence are basically what got us into this mess via giving us the food environment that we have. And now technology and affluence are hopefully going to get us out of it. But I would say if we are hitting peak and coming back down, the most likely mechanism for that is going to be the new weight loss drugs, the GLP-1s.
I can't wait to get to that. Let's drill in on a few points before that, because I think I just want people to hear this. What you said is that not everybody has the same susceptibility to obesity, right? So you put two people in the same food environment, you give them the same level of exercise. One person might become obese, another might not. I think that's really important for people to hear, right? There is this susceptibility genetically that different people have. And I just wanted, maybe if you can elaborate a little bit about that. And then the other point I wanted to highlight is that, you talked about, this includes 18-year-olds in these statistics, 43% of people in the US are obese. What is, what is the difference over the lifespan of our risk? And also, what about metabolic rate? Does this change over our lifespan? I think we've heard, when you're young, you can eat whatever you want, and then when you're older, you gotta cut back, right? Is that true? To what extent is that true? Can you give us a little bit of detail around that?
All right, so I'm going to answer your first question, and then I'm going to forget your second question. So ask me the second question again after I've answered the first one.
Sounds good.
So I think it is important that we have different susceptibilities, and a lot of that is genetic. And there are studies that have quantified this. And I don't think it should be surprising. I mean, I think we should have a very strong belief or opinion that anything you care to measure that varies between humans is going to have a genetic component to it. Almost anything. Mm-hmm. And body fatness is no different. And so there are studies that have measured the genetic contribution to differences in body fatness between people. And depending on what studies you look at, they will say anywhere between about 40 to 80% of the differences in body fatness between people is due to genetics. And I don't think this should be surprising, because we all know people who seem like they're doing everything right and they're gaining weight and they're trying so hard. And then we also know people who just don't care at all and they're skinny as rails, right? And why is that? Why is it that some people can have a plate of delicious food in front of them and they'll pick at it and not eat very much and then be done, whereas others just will eat whatever's in front of them and have a hard time stopping? Like, why are intrinsic? It's not like people chose to be like that, right? Like, these are intrinsic drives.
It's not willpower, right? Is that what I'm hearing you say?
Well,
is that part of it? To what extent? What extent is this like? Because the reason I highlight this genetic issue is that, yes, it should seem obvious. Yet I'm sure you come across this a lot, where it's like, oh, just quit eating so much, right? It sort of puts the blame on the individual. So I'm just trying to disentangle.
And my book really focuses on things other than willpower, like non-conscious drivers. But I don't want to completely dismiss willpower either, because I think it is a factor. And I think it also is something that's genetically influenced. So, it's all genes and environment, right? And part of willpower is genetic, just like everything else. And this is another point I want to make, is the variability. Like, when you look at the genetics that determine whether someone is lean or has obesity, in part determine, of course, it's not 100%. When you look at the genetics, it's primarily the genetics of the brain and the nervous system. So the way that our brain develops and the way that it operates after development and the impact of our genes on that, that's the primary thing that's determining how much fat people have on their bodies in terms of the genetics of it. And so I think that's really telling, because there are a lot of theories out there about its metabolism, its insulin, it's this or that. And really, the genetics puts the focus squarely on the brain. And I think that's really important to understand. And of course, that's part of why my book is all about the role of the brain in eating behavior and obesity, because I think that's really the organ system that this issue revolves around primarily.
Right. Okay. So then the second question, which you asked me to repeat, is really about over the lifespan. What is the risk of obesity over the lifespan? And does our metabolic rate change as we age, as we grow up? We often hear people say, I could eat whatever I wanted when I was younger. Now I have to be really careful. Can you explain that to us?
Yeah. This is a really interesting topic. So if you look at, again, you go back to hunter-gatherers and subsistence farmers, there are studies that have measured their body fatness over time, at different ages. And what you tend to see, I think it can vary somewhat between cultures, but most of the data that I've seen is that body fatness is essentially almost constant throughout life. So there's very little gain in fat. For men, it's very constant throughout life. For women, around peak reproductive years would be peak weight and body fatness. And then after that, they actually often will lose fat. And then there's kind of, with aging, there is a gradual loss of muscle mass, which is similar to what you see in our culture. And so really you don't see the accumulation of body fatness with age in at least many of these cultures. And of course, that's very different than the trajectory that we see in a country like the United States or countries in Western Europe, where typically people accumulate fat gradually over the course of their lives until a certain point, actually. And once you become elderly, people actually do start losing fat again. And then you see that muscle mass also tends to decline after 20s or 30s. And in terms of metabolic rate, so this is also a really interesting question. And Herman Poncer, who I mentioned earlier for his work with the Hadza, he has a paper on this in collaboration with John Speakman, who's another obesity and metabolic rate researcher. And they analyze tons of data of people of different ages. And what they see is that your metabolic rate per, I'm hoping I'm going to get this right, metabolic rate per unit lean mass kind of stays the same until you're about 70. And then it starts to go down. However, people do lose lean mass over time and they become less physically active. And so I think it is true that people need to eat less even before they turn 70, but particularly when people become elderly, I think that's when your mass-specific metabolic rate really starts to drop. But even before that, if you're losing lean mass just from age and physical inactivity, your energy needs are going to go down. So you will not need to eat as much. Or if you continue to eat the same amount, you'll start gaining fat. So yeah, we see a gradual fattening over time. And at least in the early part of those years, it's mostly because we're gradually eating more calories. If you look at the relationship between body fatness and calorie intake, a person who is overweight eats about 10% more calories than a lean person. A person who has obesity eats something like 20 to 35% more calories. They're not huge differences, right? Like, I think people often in their minds, they think, oh, someone with obesity must eat like twice as many calories as me, but it's not like that. It's like a quarter more. The difference is small enough that it wouldn't even necessarily be obvious to a person who is just observing them eat, right, in a casual setting. And so, but it is causal in elevated body fatness. We know that because if you reduce their calorie intake by 25% back to the calorie intake of a lean person, they lose fat.
Yeah, just adds up over time.
Yeah.
So I think a lot of people would be sort of surprised to hear that our metabolism doesn't, if I hear you right, it doesn't tend to really slow very much until older age.
So let me clarify a little bit. It may have been a bit confusing. There are two different concepts. There's your total metabolic rate, and then there's your lean mass specific metabolic rate.
Okay.
So your lean mass specific metabolic rate, so like will just say how much your muscles and brain and liver and other lean tissues are burning per pound stays about the same till you're about 70.
Okay.
However, your lean mass does go down. So your total metabolic rate, your energy needs does gradually decline, but just from the loss of lean mass after your 20s or 30s.
Okay. So it's not the age itself. It's not aging necessarily. It's the consequence of losing that lean mass. So if you can maintain that lean mass until 70.
Until you're 70. Yeah. Then it is aging also.
So I think people still would be surprised to see that. And if so, potentially, as we get into middle age, there's kind of a few things going on. Maybe there's a reduction in lean mass, of course. I think that's certainly possible. And then maybe there's also, as you said, likely increased consumption, maybe reduced physical activity. I think people often refer back to their youth. Maybe they were an athlete. Maybe they were in PE, maybe they were doing pickup games of sports. And so, of course, they ate kind of whatever they wanted because they were burning a lot of those, calories. And so maybe their lifestyle now is quite a bit different, right? So that could be a part of it. I want to talk about leptin. So many listeners probably won't have heard of leptin. And I think it's really important when you talk about the role of the brain in obesity. And then we'll get to GLP-1 drugs after that. But can you tell us what is leptin and why does it matter?
Yeah, this is the most important body fat regulating hormone that people have never heard of, that many people have never heard of.
So let people hear of it.
Yeah. So leptin is the primary known body fat regulating hormone in the body. It is produced by fat cells in proportion to their mass. So the more body fat you have, the more leptin enters your circulation. And it's used by your brain as a signal to regulate your body fatness. So essentially, your brain is listening to how much leptin is in your bloodstream as a measure of how much fat you have. And it's using that to coordinate responses related to body fat, like your appetite, your cravings, your metabolic rate, things like that. And so the main way that it works is that, let's say you go on a diet and you lose 10 pounds, most of that is body fat. Let's say 7 of that is body fat. Your leptin is going to drop. Your brain gets the signal, primarily a part of your brain called the hypothalamus, gets a signal that your leptin has dropped, and that activates what I call the starvation response, which is alarm bells start going off and your brain says, we're losing body fat. This is a dangerous situation. Your brain still thinks it's on the Serengeti, right? And if you're losing body fat, you might be about to starve. And it activates this starvation response that cranks up your hunger and may lower your metabolic rate a bit, increases your cravings, increases food-seeking behavior until you have restored your body fat to its previous level. And then it shuts off and it's like, okay, we're good. And
so like a set point.
Yeah, some people object to that term, but I think it's useful. Essentially, there's a certain amount of leptin that your brain is looking for. And if it drops below that, it activates the starvation response until it comes back up. And that's one of the key reasons why people struggle with long-term weight loss maintenance, is these responses, they undermine your weight loss effort. So you're, eating a healthy diet, you're cutting back on your calories, you're doing what you can do to lose weight. And then gradually, as you lose weight, this opposite force is building and building and building in the non-conscious parts of your brain and pushing you to eat more and more and more. And it becomes more and more difficult for you to maintain that loss and those healthy lifestyle behaviors. And in most cases, people, they can't maintain it and they regain the majority of the weight that they lost. And that's what you see in most diet trials, is even if you have a really intensive intervention, really great support, a really great diet, follow people up at 2 years, and generally they will have regained the majority. Even at 1 year, typically, they will have regained the majority. 2 years, almost every study, they've regained the majority of the weight. And so I think
that will be validating for people to hear there's something causing that struggle to keep the weight off, right? It can be so easy sometimes to lose the weight. And I think I've heard a lot of people say, the best diet is one that you can maintain long term, because there is this role of leptin, as you're telling us, that it's not easy for our brain to just maintain this new lower, level, right?
Yeah, that's right. One of the pieces of unexpected feedback that I got from my book that I really appreciate is a lot of people came back to me and they said, I feel like it feels like a huge relief knowing that it's not just, me and my decisions that have caused me to regain weight over time, that there are actually these non-conscious brain systems, this biology that's pushing back. It allows me to feel like, okay, I'm not just a failure who can't do this. Like, there are actually really powerful systems that are causing this to happen that I just didn't really fully appreciate at the time.
Yeah, that's really powerful. There's forces at play that are, people are facing that makes this very difficult.
Yeah.
I think you also mentioned something which I very, very briefly you mentioned, which I want to talk a little bit more about, is that, we evolved in this time of scarcity. We, for millions of years, we did not have access to really eat too much. It wasn't particularly easy to do that. The types of foods we had, right? The amount of food, the amount of effort we had to expend to obtain food. And so there's sort of this mismatch. Like, we were, our bodies were very good, at adapting to our environment, but we haven't sort of caught it. We didn't have a chance to suddenly evolve over this, maybe the last 100 years, or thinking about the Industrial Revolution, or thinking about even agriculture 10,000 years ago. How do we adjust to this when our bodies are sort of made for a different time before this modern food environment?
Yeah, it's I think that concept of evolutionary mismatch is really important, and I think we're experiencing a lot of evolutionary mismatches in the modern world because we have so dramatically exited our historical ecological niche. Like, humans lived as foragers for millions of years, and then farmers for 10,000. In the last 100 years, our lives have changed so radically in so many ways. Now, with our food environment, our digital environment, media, it's like, and our unprecedented control over our own lives, really. Like, we have the ability to stimulate ourselves in ways that we never did historically, through food, through entertainment, pornography, gambling, drugs. Like, we have all these technologies that are novel and that are extremely stimulating to the human brain. And it's not all bad. Like, we're not starving anymore, right? Like, in the United States, we have this incredible food system. It's not like an unmitigated disaster. There are some wonderful things about it, but
Right.
but there are downsides. There are things that we're just not adapted to. And I think the food environment is one of those things. It's like trying to take a white-skinned person living in Kenya. Like, we don't have skin that's adapted to that sunlight, right? That kind of sunlight,
Mm-hmm.
living outside in that. I think it's similar. Our brains are not adapted to, the brains of all humans are not adapted to the modern food environment.
Right. So now, while we're still talking about food, before we move on to drugs, which I want to get to, different, drugs that can influence obesity, which obviously is a hot topic now, I want to just touch on, we don't have to spend a lot of time on it if you don't want to, but there's something called the energy balance model and the carbohydrate insulin model. You can correct me if I'm wrong, but there are debates going on. They've been going on for years. They're still going on. Folks like David Ludwig, who's sort of more of a proponent of this carbohydrate insulin model, and I think others. I think where your side, where you're kind of like maybe that's not the best explanation of what drives obesity. Can you tell us what these different models of obesity are? Try to steelman the case for the carbohydrate insulin model if you can, and then after that explain what your view is and why you've come to that conclusion.
Yeah, so the energy balance model is kind of a top-down model where the amount of fat in our fat tissue is determined by the energy that we're eating and all the factors that determine that, and the energy that we're expending as well, and the balance between those two. Carbohydrate insulin model is a bottom-up approach that's saying, well, the real driver of this process is fat cells themselves and the metabolic processes that impact their uptake of fat. So they're not just passive reservoirs that are receiving excess energy that we eat and storing it. They're actually in the driver's seat driving this fattening process. And if we're overeating, it's because our fat cells are being impacted by this process and sucking energy out of our bloodstream, and that's what's causing us to overeat. So it's kind of changing the causal arrows. I think so. There are many different versions of the carbohydrate insulin model, and I think the one that I'm most confident is not correct is the one that says that the primary cause of common obesity is elevated insulin caused by eating too much carbohydrate, packing fat into fat cells. I think we have an abundance of evidence that that is not correct. What I'm not as confident about is, could there be a smaller effect? Like, instead of this being the main cause, could it be something that partially contributes? Could it be contributing in a subset of people with certain atypical metabolic factors going on? Could it be more impactful in, I don't know, certain people with certain kind of conditions? And I think, and the more we broaden the mechanism, so if we say, okay, it's not just elevated insulin, but maybe different parts of the insulin signaling pathway and different tissues, then it becomes harder to refute. So the smaller the effect size is and the more complex the hypothesis, you can't really say, no, we can definitely reject this, because we don't really have the evidence to do so. But I think the strong version of the hypothesis that I articulated, that it's the main driver, I think we have tons of evidence that is more than sufficient to put that one to bed. One thing is, if you just measure people's insulin level, so if you take like 100 people, you measure how much their fasting insulin is, and you measure how much insulin they produce in response to a meal or a controlled dose of glucose, and then you just follow them up for 10 years, the amount of insulin they're producing does not reliably predict how much fat they're going to gain over time. Most studies have found that it doesn't predict it at all, or even it's the opposite of what you would expect. There's less fat gain in people who are secreting more insulin. And so they're just like really basic predictions like this that I feel like people aren't really testing in a rigor, or they're not really thinking about it. The proponents aren't really thinking about this in a rigorous way. And then, because that's like the first question you would ask, right? If that's your hypothesis, that's like the first question you would ask. And then another thing that I think is really telling is the genetics of obesity. So if you think the primary mechanism of body fat accumulation is insulin signaling or something to do with fat cells, that should be showing up in the genetics that's impacting who is leaner and who is fatter, right? but it doesn't. If you look at the genes that are if you look at the tissues and the biological pathways that are particularly enriched in obesity genetics, it really revolves around the brain. It's not revolving around insulin. It's not revolving around the pancreas. It's not revolving around insulin receptors. It's not revolving around fat cells. It's revolving around the brain and the nervous system. And there are other conditions where it does revolve around insulin. So it's not like these studies are inadequate to detect it if that's what's happening. Like if you look at diabetes, the genetics does revolve around insulin and the pancreas. And so, but when you look at obesity, the tissue that keeps popping up, the brain, and then the biological pathways are so heavily enriched. So obesity genetics is so heavily enriched for brain stuff that it looks like a psychiatric disorder. Like, wow. I'm not saying it is a psychiatric disorder. I'm just saying that it is as enriched for brain genetics as things like psychiatric disorders like schizophrenia or intelligence. That like the things that we know are all about the brain. It's at that level in terms of how enriched the brain genetics are in obesity. And so like, I just don't understand how you could get a signal like that and continue to think that it's not about the brain or not mostly about the brain, because these studies where those data come from, genome-wide association studies, these are some of the most rigorous and replicable studies in all of biomedical science. And one of the key things that I think is really important about them is that they're relatively unbiased. So they scan the entire genome and they look for locations in the genome that are associated with a trait. So like if you have a certain gene variant here, you're going to be slightly heavier. If you have this other one over here, you're going to be slightly leaner. There's no hypothesis, like just whatever pops up. And then they take all those signals and they run it through these algorithms that tell them, what tissue is showing up most, what biological pathway is showing up most. It's not like they're looking under the lamppost and saying, okay, we're neuroscientists, so we're looking for brain genes. No, they're looking for anything, whatever pops up. It's very unbiased, and the brain is just what pops up. And so to me, like, there's a lot of ideology and entrenched ideas in obesity, especially the public discourse, but even in the scientific world. And to me, that type of study is a way to say, like, okay, let's get a check on our thinking here. Let's look at the most unbiased, most rigorous type of evidence that we have and let it inform our thinking.
Okay. So very technical for a lot of people, but I appreciate you going into that. I think we're going to shift just a little bit more specific about the foods. When we talk about food environment, we didn't really talk much about what we're talking about, like what about our food system. So I want to talk a little bit about ultra processed foods, which are these highly processed, highly refined formulations. So it's the products that you typically see packaged, right? Doritos, donuts, chips, these types of things. So what is it about the foods that we eat? What is it about ultra processed foods? What is it about other foods maybe that aren't ultra processed? How does the design of these products cause us to overeat them by so much?
Yeah, that's a really good question. There are different camps on this. There are some camps that say that we basically know what causes people to overeat with ultra-processed foods or certain ultra-processed foods. There are other camps that say we don't have enough information, we need to do more studies. Kevin Hall is in that camp. And then there are other people who say that the label ultra-processed food is not really useful because some foods that we call ultra-processed, for example, like whole grain packaged bread, might actually be fine. And other foods that are not ultra processed, like butter or bacon, might not be healthy. And so I think there are debates on both of those, and we can put those debates aside for now. But I think we can at least start with the assumption that at least some ultra processed foods are in fact fattening, and probably many of the foods that are most fattening do fall in that category. The foods that are really calorie dense and seductive that we tend to eat too much of. And I think we do know a fair bit about why these foods tend to be fattening. I think one reason is that they have a low satiety per calorie. And this is essentially what that means is that per unit calorie, many ultra processed foods don't make you feel as full. So something like pizza, you have to eat more calories of pizza until you feel full than if you were having a dinner of, let's say, steamed broccoli and salmon and a baked potato.
Right.
So, and that relates to some properties that we know about, like calorie density. How many calories per gram does it have? How concentrated are the calories in it? As well as the amount of fiber in it and palatability. How good does it taste? So essentially, if you have foods that are more calorie dense, protein, forgot to mention that. Lower protein is less filling per calorie. And so if you have foods that are very calorie dense, low protein, low fiber, and highly palatable, those are the foods that you're going to tend to overconsume to even just to get to the same level of fullness. So this is something I think it's important to understand is, you sit down at the table, most of us, we aren't counting calories while we're eating, right? We're not like, oh, this bite had 100 calories in that. It's like you just eat till you feel satisfied, right? And then you stop. And what is that feeling of satisfaction? What is that feeling of fullness? That's satiety. That's your brain saying, based on the signals we've gotten from the digestive tract, from the mouth, I think that you've had enough. And so it cuts off your motivational drive to continue eating. And that process primarily happens in the brainstem, part of the brain called the brainstem. And then it propagates to the rest of your brain that's responsible for motivation and for moving your body to grab the fork and put the food in your mouth, etc. And that's important because if it takes more calories to get there, to get to that point of comfortable satiety, then you're going to eat more calories without even realizing it. And that's why the satiety per calorie is so important. And it varies greatly between foods. So those foods that I was talking about earlier, where you have high calorie density, lower protein, lower fiber, higher palatability, that describes a lot of the things that we would call junk food that we know is fattening, right? Like that's pizza, that's candy bars, that's cookies, that's snack foods like potato chips, French fries, all that stuff that we understand pretty well is fattening on a, common sense level. That all fits into that low satiety per calorie because of these very simple, well-described properties, physical and chemical properties of those foods. So I think
I'm getting hungry just hearing you talk about those foods, and I wasn't hungry before. So.
Yeah, that happens. It's the food cues, right? They stimulate your reward systems, your motivational drives.
I think one thing that I just want to highlight is that you're talking about more than just the nutrients in the foods. The nutrients matter, right? The protein content matters, the calorie density matters, the fiber matters, but there's something else that matters too. You've said things like palatability, or you know, how much does it make you feel full? There's this aspect of ultra processing that is about highly refined ingredients. It's combinations of starch and fat, the right amount of sweet and salty or savory, So these sort of formulations that I think are driving some of this, these foods are delicious. They're hard to stop eating.
Yeah, absolutely. And this is the next place I was going to go is, we live in a competitive capitalist environment, and it's sink or swim in the grocery store, right? In terms of those products competing with one another. It's extremely stiff competition. And so these food manufacturers are trying to optimize everything they can to drive purchase behavior. And one of the things they're optimizing is how seductive these foods are, how much they titillate our motivational systems in our brain that determine how much of a drive we have to put that food in the grocery cart and eat it when we get home. Mm-hmm. And so when you start to combine, and what does the brain respond to? Like, what determines that seductiveness? You hit the nail on the head with the carbs and fat together, combination of carbohydrate and fat in a really calorie dense package. You take all these substances that the brain intrinsically responds to with dopamine signals like salt and sugar and fat and starch. You take out all this stuff the brain doesn't like the bitterness, the fiber, and you combine those together into, these really optimized combinations. And by the way, grandma can do this too when she's baking cookies. It's not just food manufacturers that know how to do this, but they're just really good at doing it like cheaply and conveniently. But you put these things together in these seductive combinations that just overstimulate our drive to eat. And this is just a kind of a predictable result of having this, competitive food environment where companies are having to compete for our stomach share.
Right. Well, I really would like to shift to GLP-1 agonist. And for those who haven't heard of these drugs, like I think common terms like Ozempic or semaglutide, can you tell us a little bit about what these are? They're obviously recently become much more available on the market, but give us a little bit of an overview and what's your take on these drugs for obesity?
Yeah, so GLP-1 stands for glucagon-like peptide 1. It was identified in the 80s, if I'm recalling correctly, through genetic methods. And at first, people didn't know what it did, and they did experiments to figure out what this new hormone did. And they pretty quickly figured out that it increases insulin secretion by the pancreas. So specifically, they found that when it's administered at the same time that blood glucose is hitting the bloodstream, it helps increase the secretion of insulin. So it's like when you eat food and you need that insulin to process the carbohydrates you ate, glucagon-like peptide 1, GLP-1, is a hormone that's secreted that helps bump that insulin up so your body can properly metabolize that carbohydrate. That was the initial thing that they found about it. And they said, okay, this looks really useful. We should patent this for the treatment of type 2 diabetes, because type 2 diabetes is a disorder of relative insulin insufficiency. People aren't secreting enough insulin to keep up with demand, and so their blood glucose goes way up. Mm-hmm. And then shortly after that, they discovered that it has another role. It suppresses appetite. But it wasn't it was looking a lot better for diabetes than for appetite. Actually, let me take a step back here. They initially commercialized it for type 2 diabetes. That was the initial use for it. But as the pharma companies got their hands on it and started tinkering with it, they noticed that there were some variants of these drugs that had larger effects on appetite and body fatness. And essentially what they were doing, a major thing that they were doing is creating variants of this hormone that have a longer half-life. So instead of getting degraded in just a few minutes in the bloodstream, now you can take a shot once a week and it will circulate in your bloodstream for an entire week or longer. And so this led to the development of the current crop of GLP-1 receptor agonists that are now used for both diabetes and obesity. And so in the context of this conversation, we're mostly talking about body fat. And the two drugs on the market that are most effective in the United States in this regard are semaglutide, which is Wegovy, and Mounjaro, which is Zepbound. Those are the drugs that are the GLP-1 drugs that are currently FDA approved for the treatment of obesity. And basically the way these drugs work is they actually work kind of different than the hormone. The natural hormone, only a little bit of it gets into your brain, but these drugs get into your brain quite a bit, and they trip these satiety signaling pathways in your brainstem. So earlier we talked about how satiety or fullness is regulated by the brainstem, and one of the signals it uses within the brainstem, like neuron to neuron, is GLP-1. And so when you get this drug going into the brain, it activates those receptors in your satiety or fullness signaling in your brain, and it basically cranks up your fullness way up. And that causes people to eat less, and they lose weight, and they get metabolic benefits at the same time.
Wow. Okay, so they make you feel full. They make you not crave more food. I'm getting sad about that because I one of the biggest things I look forward to is when I'm hungry again, so that I can eat, because I really enjoy eating. But so what I'm hearing is maybe you can eat whatever you want. I mean, I'm not saying that's what you should do, but can you do that? Some people may think, okay, are these drugs sort of a replacement for having to worry about what I eat?
They can be that. So I think regardless of what you eat, most people will lose a substantial amount of weight when they go on these drugs. That said, I think one of the best ways that these drugs can be used is to facilitate healthier diet and lifestyle. And that's the way that many people have advocated for these drugs. And I think that's where you're going to get the best effect. So earlier we talked about leptin and the brain and how there's this regulatory signal that this starvation response that turns on when you lose weight. Well, the main way that works, the most powerful lever that activates is your appetite. And so when you have a drug that's cutting your appetite at the same time as you're losing weight, it allows you to lose weight without that strong pushback from the brain. And our experience from these drugs show that strategy is quite effective. And I think these drugs do more than that. They do more than cut your appetite. They also actually have important effects on cravings and the seductiveness of food. And I think those may be at least partly independent of the effects on appetite, because you see that people also drink less alcohol, they use less drugs, they do less online shopping anecdotally. So like all of these kind of like excessive reward driven behaviors that we can have in modern life get curbed by this drug. So I think they're hitting our food intake by two different angles: the pure appetite angle, and then the kind of cravings and seductiveness, food seductiveness angle. And I think that's really part of what makes them so effective. But another thing
it sounds really promising, right? Those are some pretty huge impacts. I mean, you can go into a little bit about how effective they are, but to be able to overcome something where, you've tried everything, you've tried diet, you've tried exercise alone, right? You've tried all those things together and you're still struggling. What a relief probably to know, there may be something out there And also, it sounds like maybe these drugs make us more responsible people. Maybe there's a lot of these impulses that we're giving into. So I think there's some potential benefits, maybe beyond just the diet aspect.
Yeah, I think that's right. And, at the risk of sounding like a shill, I'll just say, first of all, I have no relationship, financial or otherwise, to any pharma company, just so people know. They kind of look like miracle drugs. I mean, they reduce body fatness, they reduce cardiovascular risk, they reduce diabetes risk, they reduce all-cause mortality, risk of dying. They seem to reduce like knee osteoarthritis. Now there's studies looking at potential to help with dementia, with addiction. So like, it's kind of amazing. Like we normally think of drugs as having negative, harmful side effects, right? And there are some with these drugs too, but they have a lot of positive side effects. I don't think people are used to thinking of positive side effects, but these drugs seem to have a lot of them. But yeah, let's talk about effectiveness, because I think that's important. The kind of benchmark to me of a relatively effective dietary intervention for weight loss is 5% loss of body weight in a person with obesity. If a diet can give 5% or more loss of body weight that's relatively sustained, like let's say past a year, I'm going to say, okay, this is one of the more effective interventions I've seen.
Right.
These drugs, and up until these drugs, that's kind of the range that weight loss drugs were at. So many weight loss drugs, most of them fell into two categories, the FDA approved ones. They were either repurposed psychiatric drugs, where there's some psychiatric drug that people noticed happened to cause weight loss, and they said, hey, let's use this as a weight loss drug. Or they were drugs that blocked the absorption of some nutrient, like fat absorption, for example. And none of those prior to the GLP-1s were very effective. You were looking at kind of maybe 5% weight loss on the upper end of what some of the studies were showing.
Okay. So similar to diet.
Yeah, pretty similar. So now we shift to semaglutide, which is the first really effective GLP-1 for body fat loss. And those trials were showing 15 to 18% loss of body weight. And it was sustained. Like, as long as they were able to measure it out to up to 2 years, people were not regaining that weight. So that's like a whole different level of effectiveness. And now we have tirzepatide, which is it's actually a dual agonist, meaning it doesn't just target GLP-1, it targets another receptor called GIP, which is in a similar kind of brainstem satiety signaling pathway. And that one's even more effective. So that one, we're seeing weight losses more in the range of 20% in randomized controlled trials. And so these drugs, and there are other ones, by the way, that are not quite through the approval pipeline that are even more effective. And so we very rapidly went from a point where weight loss drugs were it was a toss-up whether it was even worth trying to use them, because they weren't that effective and the side effects were pretty bad, or not worth it, let's say. And then very rapidly went to a point where we can cause people to lose a fifth to a quarter of their body weight, which is similar to bariatric surgery, so weight loss surgery. So
Wow.
Essentially we went from like barely effective to almost as effective as the most effective weight loss intervention we have over the course of just like 10 years. So it's been incredible. It's been an incredible ride.
Yeah, it's kind of amazing to hear the impact. I want to just maybe talk a little bit about the practical considerations here. You mentioned there were not necessarily a lot of negative side effects, many positive side effects, which I think we typically think of something negative when we hear side effect. But can you go into any of the potential risks or side effects that we're aware of, and any you might be concerned about, or are there really none you're concerned about? And then talk to us about, are these drugs affordable? Are they accessible? Are there going to be, are there pills people can take, or is it only injections?
Yeah, all good questions. So there are no side effects that I'm concerned about, but there are side effects that can be unpleasant. So when people first initiate GLP-1 drugs, there are typically some gastrointestinal side effects, so gut side effects. People often report nausea, sometimes there's vomiting, sometimes there's just kind of discomfort there can be diarrhea, other symptoms like that. And that typically happens during the escalation phase. So when your body is still getting used to the drug and you're gradually increasing the dose, your body is adjusting. Most people will fully adjust to those drugs and they will not have those symptoms anymore. But not everyone. Some people will have ongoing discomfort. And I think most people will experience, at least to some degree, initially some of those symptoms. And so that's really the main side effect that I'm concerned about. And then in terms of cost, it really depends on where in the world you live. So if you live in the United States, these drugs are extremely expensive. I'm not up to date on the latest prices, but up until relatively recently, you'd be looking at something like $1,400 a month before insurance. I think there's more diversity in the market now, so I don't know, maybe you can get it for somewhat cheaper. But importantly, the cost everywhere else in the world is like a quarter of that. So Americans are paying way more for GLP-1s than anybody else. And of course, the figures I just cited, that's pre-insurance. I don't know what
Right.
people are paying after insurance. That depends on whatever. So yeah, in the United States, they're very expensive drugs. In other places, they're still relatively expensive. Even 1/4 of that is still a relatively expensive drug. And they are injected. So that is something that I think can be difficult for some people or unpleasant. It's a very fine needle and it's a once weekly injection. I think people who are not particularly squeamish about needles don't have a problem with it. And it's only once a week, so it's not like you're having to inject yourself every day. But I think it's somewhat of a barrier, and it's a biologic, so it's not a pill. It's it's a liquid that you have to inject. It's basically a hormone, and so that makes it, it's got to have a cold chain. It has expiration date, etc. Whereas a pill is a lot more forgiving. There are pill versions that are being developed. They're not at the same level of effectiveness yet, but I feel pretty optimistic that we will eventually get there.
Okay. So right now, especially in the US, they're pretty cost prohibitive. So people who are wealthy and can afford it, that's awesome. Hopefully in the future these come down. I was encouraged by hearing from Dr. Jay Bhattacharya, the new director of the NIH, who said they're working on potentially reducing the price of these drugs in the US. And so maybe potentially over time these will come down. So that's okay. So that's fascinating. I know these drugs are obviously controversial, and I think there's a lot of different perspectives on them. There's a whole spectrum of perspectives. I think one thing I would add is that you still want to eat healthy, and you still want to exercise. There's a lot of reasons to get your nutrients. We didn't really talk about nutrient adequacy or nutrient deficiencies. We didn't talk about brain health or other aspects of health. So there's a lot of reasons to eat healthy, and I think you said that at the start. These drugs are really best used, in conjunction with a healthy diet and lifestyle as well. I want to go a little bit beyond obesity because we've focused a lot on obesity, and can we go into, for a little bit here, other aspects of health? So things about diet, and we can stick with diet if we want to here, but really, what else matters? So obesity is one thing, but what about other health markers, cholesterol, blood sugar, nutrient deficiencies like iron deficiency, and then just overall, how do you sort of view diet and lifestyle in terms of health beyond obesity?
Yeah. So I think body fatness is one of the most important modifiable risk factors for all the health conditions that we don't want to have, especially in a country like the United States that has a lot of excess body fatness. But it's definitely not the only risk factor. I don't think that's true at all. And I think diet quality is an important lever, even independently of its impact on body fatness. I think physical activity is important, independent of its impact on body fatness. So, I think many of the conditions that we're experiencing, like especially type 2 diabetes, but even to a lesser extent, cardiovascular disease and many other common conditions, are diseases of energy excess. So essentially, we're eating too much and our body fat is too full, and you have all this extra energy, fatty acids and glucose, spilling over onto tissues in levels that they're not prepared to constructively handle. And that causes all kinds of problems. Physical activity, you're creating a massive energy sink in the form of muscular contractions. And so I think it's pretty good at mitigating some of the problems with overnutrition, eating too many calories. And then there's other things like sleep and stress. I think mental health is pretty important, certainly for quality of life, but also for health. And then there's also, the kind of harmful lifestyle habits like smoking and drug use that are also important.
Right. Okay, so before we move on to, I think we want to get to the health information environment because we have a lot to talk about there, but I wanted to just sort of close on the diet side of things, thinking about brain health. And, is there anything in the diet that really impacts brain health? Are there certain types of foods that are particularly good for brain health?
Yeah, this is a good question. I have kind of lightly followed the literature on this for many years and have not been very convinced by any of what I've seen in this area. There are a lot of claims about this and that food or supplement impacting brain health. There's not a lot of evidence that they actually matter for the conditions that we care about, like Alzheimer's disease, for example. And so I'm still in the camp of just kind of generally take care of your body and eat a healthy diet, and that's probably going to be good for your brain. And aside from that, we don't really know a whole lot. Though I will say one thing. Okay, this is probably the most direct thing I can say about this, or the most specific thing I can say is that cardiovascular health impacts brain health. And so to the extent you can keep your cardiovascular system healthy via diet, physical activity, and if needed, drugs to control your cholesterol, that's going to down the road probably pay dividends in terms of your risk of developing dementia.
Okay. Take care of your heart and it will take care of your brain. Okay, so let's move on. Let's shift to the health information environment, which is a phrase that many people may not have heard. So maybe we can just start with, what does that mean? What is the health information environment? And yeah, we'll go from there.
Yeah, so the health information environment is all of the information that as a culture and as individuals we're steeped in that pertains to health. So whatever you may come across on the internet, whatever you may see on social media, in the news, from your friends, in that book you read, that's your health information environment. It's just where you're getting your information about health.
Okay. So more specifically within this, environment, what defines high quality nutrition information, dietary information?
Yeah, that's a really good question. I think um, that that is actually, I think, a pretty complex question to answer. What defines high quality information? I think probably the easiest way to answer it is that we want to look for certain hallmarks in that information and in the people who are providing that information, hallmarks of information quality. So, are they citing references when they provide that information? When you look at the reference, does it say what they say it says? Um, and the information they're using, is it representative of what of the research that is on that particular topic, or do they just happen to cherry pick one study that showed something that's different than what every other study showed? What is the quality of that underlying evidence? Are they citing studies with rigorous designs? Do those studies have limitations? Are they telling you what those limitations are? Those are the kinds of things that you want to be thinking about when you're assessing information quality. And I think for the average person who's not a researcher, who's not used to thinking in this way, who doesn't really have time to go through this process for every piece of information they receive, I think it's a really tall order. And so I don't think it is reasonable to expect the average person to apply a rigorous evaluation process to the health information that they're consuming. And so that's why I think we need organizations like Red Pen Reviews, where you have people who are applying a rigorous process and are doing it in the time consuming but rigorous way, so that you can provide that evaluation to people who don't have the time, don't have the capacity to do that sort of thing.
Okay. Yeah. So let's just pause here and just maybe I can share that Red Pen Reviews is something that you, Stephan, have founded, and have other experts who kind of work on this to publish expert reviews on popular nutrition books. So it's sort of what you're talking about is you're doing the work so that the general public doesn't have to try to sift through the noise. And I think nutrition specifically has quite a bit of noise out there, right? There's a lot of hype. There's a lot of influence from people who may not be qualified in the area they're talking about. There's a lot of confusing information. There's a lot of conflicting information out there. And especially, moving not just in the science, I think most of it actually comes in context like social media and on popular books and on podcasts like we're having right now, right? So I think it's something I really care about, and I think our listeners will really care about, because they're wanting to know, how can we find reliable information about nutrition and health?
Yeah, so I did a literature review for an article that I wrote in Asterisk magazine a couple of years ago on all the research that's been done on the our nutrition information environment, and particularly how much misinformation is there in these different domains, like social media, like news articles, even the scientific literature has some misinformation in it. And so I tried to quantify that, and I found that actually there wasn't a lot of research on it. So there's not a lot of research that can help us say, like, okay, if you're on Twitter, half of the posts that you see about nutrition are likely to be incorrect or misleading. The best source of data that I found is actually from our organization, Red Pen Reviews. So we review popular nutrition books, and we're really selecting the most impactful books we can, like the books that people are really reading the most. And we're not trying to pick like the worst books or the best books. We're just trying to pick the books that people are reading the most and give people as accurate of a picture as we can about the information quality of those books. And we've reviewed, I think, 25 books to date, and we assign those. We have a structured review process that assigns numerical scores to scientific accuracy, reference accuracy, and healthfulness of the information in those books. And because we're applying the same process to every book, the same scoring process, we can actually compare between books, and we can compile and analyze that data as a whole because it's all comparable. And so what we see is that the information quality of nutrition books published primarily in the US is highly variable. Some books have very high information quality, and some books have absolutely awful information quality. So on our information quality score, it goes all the way up to 97%, all the way down to, I think the lowest is like in the 30s. So if you're getting down into the 30s, that means a lot of the things that you're saying are not just not supported, like the evidence actually says the opposite. And so that's like bottom of the barrel information quality. And on average, these books are scoring in the middle. So they have moderate information quality. They're scoring in the 60s on average. But if we look at the specific domains, scientific accuracy is actually the worst. So, and healthfulness is the best. So these books, most of them are giving diet advice that's not terrible. Like if you follow that advice, you're probably going to be doing better than the average American eating the average diet. Okay, that's a low bar, but that is the bar we use. And so healthfulness is actually not too bad, but the scientific accuracy is where they really suffer. It's like, how are these people justifying the diet? How are they explaining it? That's where people have all kinds of crazy ideas. And again, it varies. So some of them are very evidence-based, even in that domain. And some of them are just like completely off the rails. And yeah, that's pretty much what it looks like. So there is, just to kind of give you the highest level is that we live in a highly variable and relatively poor quality nutrition information environment. There is good information out there, and there is very bad information out there. And most of it's kind of in the middle where it's some good, some bad.
Wow. Okay. So that's a little bit concerning, just thinking that we may be hearing from different sources. We may be reading a book. Maybe the author is credentialed, maybe not. We don't necessarily know how credible is that information if we're not, scientists in that field. I think that's something that's probably helpful for people to know, so that, of course, maybe the basics of a healthy diet, eating more minimally processed, fresh foods, is pretty simple. I think there's a lot of risk of misinformation or incorrect information. So that's something that I've used on Red Pen Reviews, and it's been helpful for me in sort of kind of understanding what type of books are really more credible than others. I think that's also probably hard when we think about social media, we think about podcasts, we think about the news. So I think I really appreciate the work that you're doing, and I think we need more of it. We need to expand into other mediums if possible.
Yeah, thank you.
And one of the reasons I'm starting this podcast really is because I want to help people cut through the noise. Part of that is through screening the guests that I invite on the show, and part of that is through making sure that we're sort of having a conversation that's grounded in evidence, and that we're keeping the focus on areas we are familiar with, or we can sort of state when we're making educated guesses on something, right? So I think that's, the transparency part of it is important. I want to get your take on the role of AI in this space. How does this modify the health information environment? If you were to choose a random diet book or somebody who's an influencer on social media, and you were going to ask them a question about nutrition or diet or health, or if you're going to ask an AI model about that, which one would you prefer? Which one would you rely on? What are the benefits and potential risks of AI?
Yeah, I mean, I think if we're talking about a randomly sampled health information provider, whether it's somebody on Twitter or a news article, I would take the AI 10 times out of 10. I think that AI is the best AI models today, and even the ones that are kind of second tier, are very capable, very intelligent about general background information like health and diet, and they're really good at communicating too. So, in the interactions that I've had with AI so far, with the various leading models, I found it to be very capable at communicating evidence-based health information and doing so in a way that is accurate and relatively nuanced. I will say sometimes the models can be overconfident. This is one of the areas that I think they generally have a weak spot in, is really understanding and communicating uncertainty. So sometimes they'll, tell you things about health that maybe are not as certain as they say they are. That said, you can also prompt for that. And I think in my experience, they've been pretty responsive to that. So you can say, ask them a question, and then you say, if it's uncertain, say so. If you don't know, say you don't know. And I've gotten pretty good responses that way. I think far better than the average nutrition person might say on Twitter or in a news article.
Yeah, that's okay. Interesting to hear. I have a pretty similar experience. I think I overall trust the responses for the most part. And I think when usually when I'm doing some sort of research, that's where I can identify if a response is, correct or incorrect or flawed in some way. But one of the things that I find helpful is, especially when I really need to know the answer to something, is having the search for information online, and that includes the scientific references. And so sometimes that can be helpful to very quickly get access to a lot of the different references. So not only do you hear sort of a very clear summary of the answer to a question, but you can also find the references that back that up. And I find that valuable for sort of, trusting but verifying, giving it that, taking the time to review those.
I think you and I do work that gets quite technical. And I think when, work in nutrition that gets quite technical. And I think in that kind of environment, you hit the limits of AI in terms of knowledge, in terms of critical thinking about evidence. But yeah, in terms of just like general background information about diet and health, they're, I think, very capable.
Yeah, I'm a big fan. I think it's going to help. I think it's going to help our information environment, like you're suggesting. I think it's going to make general improvements across the board. I think one of the main maybe limitations is that these models want to please you. They have been reinforced to provide answers that you want to hear to some extent, and I think that the prompt matters. So having an interaction, maybe checking with various models the same type of question. I've even taken the response from one model to put into another, so you can kind of sense check things like that and cross-reference. But overall, I think a really good thing for the health information environment and nutrition specifically. So the last topic I wanted to ask you about is about charity and international development. And so, you're a senior researcher at GiveWell, which is an organization that really works to have an impact across the world. And this is effective altruism. It's about, which type of organizations and nonprofits are doing work that has a high impact for the investment. And so could you tell us a little bit about GiveWell and your role there, and why should we care about charity and international development?
Yeah, so GiveWell really focuses on cost-effective giving. So we receive donations from the public, and we allocate those to the most cost-effective giving opportunities we can find. So essentially, we're trying to figure out what charities are helping people the most per dollar, and we're directing funds to those charities. And it turns out that when you apply that lens, you find that most of the charities that are the most cost effective are operating in very poor countries, because you can do a lot more good. If you're a rich country, you can do a lot more good in poor countries than you can in rich countries. So,
Mm-hmm.
yeah, so I'm a senior researcher, been with GiveWell for about 7 years, and I build cost effectiveness models and do primarily intervention research. So I'm the guy who roots around in the literature, extracts effect sizes, and uses them to build the best models we can to figure out which interventions are the most cost effective. And I'm on the nutrition team, so we're working on things like severe acute malnutrition, which is like severe underweight, that can be fatal. We're working on iron supplementation, vitamin A supplementation, which reduces deaths in children in low-income, high-mortality settings. And we're considering some other things as well, more in the kind of cardiovascular and chronic disease space. But yeah, I think, GiveWell, I'll just say that I think it's a really great organization, and I really believe in the mission. It really is about helping people as much as possible. And when people donate to us, their money gets passed through 100% to the charities we direct funding to. We don't take a cut. We are independently funded. And so we're really just trying to maximize the impact. We're not trying to, siphon off money to support ourselves. So yeah, I think it's if anyone's looking for, to maximize the impact of their donations, GiveWell is a great place to look.
That's amazing. I think it's so cool to be focusing on the populations where they need the sort of basic needs the most, and you can have such a big impact. I wasn't aware that GiveWell was funded independently, so that's also amazing. The funds go directly to the organizations doing the implementation of that work.
Mm-hmm.
So that's great. Thinking about the funding landscape, we've had U.S. aid was dismantled recently, which U.S. aid was not perfect by any means. And so I think there's sort of everybody agrees that there was a lot of, work to be done to improve it. But it's hard to see that loss. And one of the things I think the community is sort of struggling with right now is, how do we meet the needs of people living in poverty around the world? Public funding, so things like USAID, taxpayer dollars, that's actually the largest source of funds to go towards these causes. And so when that is not there, and that's actually declined in many countries around the world, in Europe, for example, there's a gap and people suffer from that. And so I just want to, get your take a little bit on, sort of a call for how do we meet the needs of people around the world? And what is it that we're, maybe you can be a little bit more specific about the work that's going on, because I think people associate charity with giving people handouts, maybe, right? Like, oh, that's just giving people money, or if it's a cash transfer, or giving people products or materials, and it's not necessarily empowering them. I don't necessarily agree with that, but that's a view I've heard. And then maybe others who think, well, why is that our responsibility, in the US or in another wealthy country? Shouldn't the governments themselves be sort of providing those programs and interventions? And so maybe you can share a little bit about how can we meet the need that is now even greater because of the reduction and loss of public funds?
Yeah. Yeah, this is a meaty topic. We could talk about this all day. I will say, we were talking about the information environment earlier. The information environment around international aid in this country has been absolutely abysmal lately. There's been so much misinformation about U.S. aid, international aid, what it does, how effective it is. As you said, I think there are many people who have called for reform of U.S. aid, people who have called for reform of other government agencies that are administering international aid. And that's fine. I think that's reasonable in many cases. But, there's been just insane rhetoric like USAID is a quote unquote criminal organization, for example, was a claim on Twitter. No evidence was provided for that claim. It was just asserted. And meanwhile, it's like these organizations via US taxpayer money, which by the way is accounting for less than 1% of the national budget, are saving over 1 million lives per year because they're providing very basic services like HIV medication to people who have HIV or who might develop HIV, like kids born to mothers with HIV. Those mothers need antiretroviral drugs so their kids don't acquire HIV. People with tuberculosis, people with malaria. These are diseases that kill millions of people each year. And the United States has been historically very generous in contributing to alleviating these terrible burdens. And, I'm not going to tell anybody what their values should be. So like, if you really don't care about people in poor countries and you really don't care, I'm not going to try to convince you that's your values. But if you do care, this is one of the cheapest ways that we can help people all around the world. And, like if you believe that a human being is a human being and a human being has value and should have a good life to the extent that we can make that happen, like this is one of the best ways that we can do that is for the richest country in the world to spend a tiny fraction of our tax revenue helping other countries. And I think it's not just about helping other people, it's about helping ourselves. Like the United States, when you do that, we are viewed globally as a benefactor. Like think about all the diplomatic soft power benefits that accrues back to us, that we are like really genuinely trying to help people in need. And so I think, there's been a lot of focus on like the people who are trying to cut these programs have focused a lot on, things like DEI aspects, but the vast majority of the billions of dollars that were spent via USAID are going to much more basic, much more needed things. Like these are a drop in the bucket in terms of USAID's or USAID's overall activities. And could it be more effective? Could it be more cost effective? Yeah, probably. But that doesn't mean that it's a criminal organization, doesn't mean that it's ineffective. And I don't think most people understand just how many lives are at stake here. Like we're talking about the modeling that's been done, if you eliminate all of the US government's international health aid, that would cause like 1 million deaths a year to withdraw all of that aid. And that's not what's happening. So some of it is being retained. So it's not going to be 1 million excess deaths a year as a result of recent changes, but it's going to be in the hundreds of thousands probably, because a lot of that money and a lot of those programs have been completely shuttered and kneecapped. Like if you want to draw those programs down, that's one thing, but just completely shutting off funding throws everything into chaos. And there's hundreds of millions of dollars of commodities like anti-malarial drugs sitting in warehouses rotting because there's no one left to distribute them. Like that's not an efficient use of US taxpayer funds. So anyway, I could keep ranting about this, but the what's happening now is that there is a partial US withdrawal from international aid that is creating a gap where there is great need from people who were previously served by those programs. And at GiveWell and other private philanthropic organizations, we are trying to figure out how to fill the most urgent of those gaps. But GiveWell directs like $300 to $500 million a year. That is very small compared to the roughly $7 billion in health aid that USAID was spending. So we can't fill all these gaps. Nobody can fill all these gaps. Even the Gates Foundation can't fill all of these gaps. So we just try to do what we can and fill the most important, the most critical, the most time-sensitive gaps right now.
Right.
Let me just add one really brief thing. I just want to say that I have never received any kind of funding from USAID, and GiveWell does not receive funding. So none of my comments have, are influenced by that in any way.
Yeah, I appreciate that. For a more like positive, hopeful perspective, I think we are, as a community, are trying to think about how do we find other mechanisms to, direct money and provide support for populations that really need it most. And I think we'll hear more about that in future episodes. But I just wanted to say most of us do care about others, and I think that we can find ways to have more effective impact on people who need help the most. So appreciate everything that you were able to share with us, Stephan. I think I learned a lot from the process, even knowing a bit about your work. And if we could, if you wanted the listeners to just remember one thing from the episode, one key takeaway, what would it be?
Yeah, I think the key takeaway for me is that the United States is the richest country in all of human history, the United States in 2025. And because of that, we have the opportunity to help people who are in severe need right now in other parts of the world. And just to give an example, I think that the probably number one most positive, impactful legacy that George W. Bush had was PEPFAR, which is an HIV treatment and prevention program in Africa. And that program over the years has saved millions of lives. And that was the result of him, George W. Bush, having a positive vision of what we could do for others, how we could serve others in need. And I think that kind of positive, optimistic, giving vision is something that we're sorely lacking today in 2025. And that's something that I would really like to see in this country.
Well, that's really powerful. Thank you for sharing. And, for the listeners, if you want to find out more about GiveWell, where can they find information about GiveWell?
Yeah, so givewell.org. Our website has a wealth of information there.
Okay. Well, I've really enjoyed this conversation. We'll leave some show notes so people can find some of the resources, materials, and where to find you. Thank you so much for taking the time to speak with me.
Yeah, thank you so much, Ty.